So in the last lecture, we were discussing about what is state space form of representing a given system, right? So we had seen that a system can be broken down or can be written in terms of first order differential equation like x dot equals ax plus bu and y equals cx plus bu, where a, b, c, and d are arrays or matrices of appropriate dimensions. So keep in mind, state space representation is not unique for a given system, whereas transfer function is unique. Okay, so that means there can be always one and only one transfer function for a given system, but there can be infinite number of state space representations for the same given system. Out of which there are certain forms, there are certain kinds of representations called standard forms or canonical forms. So in this lecture, we are going to see mainly two types of canonical forms or standard forms. One is called the controllable canonical form or the phase variable canonical form, and the second one is called the observable canonical form or direct feed forward canonical form. So let's get into the details. So transfer function of a system is unique. But state space representation is not unique. That means there can be infinite number of state space models for the same system. Okay, so we are going to see mainly two types of standard forms or canonical forms. First one is called phase variable canonical form. Phase variable canonical form or controllable canonical form. Phase variable canonical form or controllable canonical form. Okay, let's take one example. Suppose you are given a transfer function like this. G of s equals b3s cube plus b2s square plus b1s plus b0 whole divided by s raised to 4 plus a3s cube plus a2s square plus a1s plus a0. Okay, so this is now given in the transfer function form. We want to find what will be the system when expressed as phase variable canonical form or controllable canonical form. So this I can write it like this. Okay, so this let this be the output and this be the input. So this is transfer function ratio of Laplace transform of output to Laplace transform of the input when all initial conditions are 0. So I can draw it like this. This is my input 1 by s raised to 4 plus a3s cube plus a2s square plus a1s plus a0. Okay, then another block which contains the numerator part b3s cube plus b2s square plus b1s plus b0, and this is the output y of s. Okay, so in between there is an intermediate variable. I call that intermediate variable as w of s. Okay, I call this intermediate variable as w of s. Okay, so I can write as the next step. I can write what w of s divided by u of s. What is that? 1 divided by s raised to 4 plus a3s cube plus a2s square plus a1s plus a0. Okay, or in time domain it means what? So s in Laplace domain is equivalent to what? D by dt in time domain. So this becomes s raised to 4 w of s, or in time domain that becomes w 4 dot t. Okay, so I will write like this: w 4 dot t plus a3 w triple dot t plus a2 w double dot t plus a1 w dot t plus a0 w of t equal to what? U of t. Okay, Now I will call this w of t as x1. Let w of t equal to x1 of t. Okay, so what will be w dot t? W dot t will be x1 dot t. Okay, that I will call as the next state variable x2 of t. So what will be w double dot t? W double dot t will be x2 dot t. Okay, I will call that as x3 of t. And what will be w triple dot t? W triple dot t will be x3 dot t. That I call as x4 of t. So our w4 dot t will be what? x4 dot t. Okay, so I can write from this equation 1. I can write what is my what is my w4 dot t? W4 dot t will be equal to what? Minus a3 w triple dot t minus a2 w double dot t minus a1 w dot t minus a0 w of t. Okay, so now instead of the w and other things, I can write in terms of state variable. So w4 dot is equal to x4 dot t. So this means x4 dot t equal to what? Minus a3 w triple dot. W triple dot is x4 of t. So a3 x4 of t minus a2 x3 of t. Why x3 of t? Because w double dot is nothing but x3 of t. Then minus a1 w dot t. W dot t is x2 of t. a1 x2 of t minus a0 x1 of t. Okay. Now what is x3 dot? X3 dot is x4. x3 dot t is x4 of t. What is x2 dot t? x2 dot t is x3 of t. And x1 dot t is nothing but x2 of t. Okay. So now it is in states. These are the state equations. Okay, so in matrix form, what you get? I can write x1 dot t, x2 dot, x3 dot, and x4 dot t must be equal to what? Some matrix into x1, x2, x3, x4. Okay, x1, x2, x3, etc. up to x4. Did I miss something here? Some u term is there, right? Equal to u of t. So equal to u of t. So this becomes plus u of t. Plus u of t. Okay, now what is x1 dot? X1 dot is x2. That means 0, 1, 0, 0. Okay, plus something into u of t. So there is no u term, so this becomes 0. What is x2 dot? X2 dot is x3. x2 dot is x3. 0, 0, 1, 0, 0. What is x3 dot? X3 dot is x4. 0, 0, 0, 1, 0. And what is x4 dot? X4 dot will be minus a0, minus a1, minus a2, minus a0, minus a1, minus a2, minus a3, and 1. Okay, so this will be our x dot vector. Okay, equal to, this is our A matrix, A into x plus B into u, standard form. Okay, so you can see here that the denominator coefficients, where do you get them from? From the denominator from the denominator of the transfer function. Straight away you can plug in those values as the last row of the A matrix in phase variable form or controllable canonical form. Okay, so it will be having an n-1 cross n-1 right square matrix whose diagonal elements are 1. Okay, so this is the right square matrix, right? 3 by 3. So the total order of system was 4th order. So n-1 by cross n-1. That means 3 by 3. Square matrix you will get. The right square matrix. Okay, whose diagonal elements are 1 and all other off diagonal elements are 0. Similarly, you can see here that the B vector has the last entry as 1. Okay, and all other entries in the B vector are 0. Okay, so this is x dot equal to ax plus bu form. Are we done with? Not yet. We are done with only half, right? Now what next? Y of s divided by w of s. Okay, y of s divided by w of s. What is W of S divided by Y of S divided by W of S? B3S cube plus B2S square plus B1S plus B0. Or from here you will get Y of T as what? B3 W triple dot T plus B2 W double dot T plus B1 W dot T plus B0 W of T. Okay, but what is W of T? We had already defined. W of T is x1. W of T is x1, W dot is x2, W double dot is x3, and W triple dot is x4. Okay, so straight away we can write B3. What was W triple dot? W triple dot was x4. So I can write B3 x4 T plus B2 x3 T plus B1 x2 T plus B0 x1 of T. So what will be my Y matrix? Y will be equal to 1, 0, 0, 0 into what? X1 of T, X2 of T, X3 of T. Sorry, Y will be, sorry. Y will be B0. This will be B0, then B1, B2, B3. Okay, X3 of T, X4 of T. Okay, plus 0 matrix into U of T. Okay, so now this is of the form Y equals Cx. Y equals Cx plus D, where D is a 0 matrix and U is the control signal, U of T signal. Okay. So this is what is called the phase variable form or canonical form. Okay. So now you see what are the state variable, what are the equations here? X1 dot equal to X2, X2 dot equal to X3, and X3 dot equal to X4. Okay. So let us try to draw signal flow graph for this. Okay. We will try drawing signal flow graph for this. Right. So let us try plugging each this thing one by one. Okay. So you see the first equation x4 dot. Okay. So there should be an input signal here U. Okay. This is U of T, or rather U of S. Okay. So its coefficient is 1. So this must be our S x4 of S. Okay. Because S x4 of S means what? X dot T in time domain. Okay. So X, what is that? Equal to minus A3 x4 T. So here there should be an integral. Okay. Because only when you integrate this, you get x4 of S. Okay. So there should be a path from x4 at a gain of minus A3. So this should be minus A3. Okay. Then if you what is x4? X4 is actually x3 dot. Okay. So that means if you integrate once again, what will you get? If you are integrating x4, what will you get? You should get x3. Okay. So this must be x3. Okay. And if you integrate once again, what will you get? You should get x2. Okay. Why? Because x2 is what? X2 dot is x3. Okay. So if you integrate x4, okay, if you integrate x4, you should get x3. If you again integrate, you should get x2. And one more integration, what will you get? You will get x1 of S. X1 of S. Okay. So what is x4 dot? X4 dot must be minus A3 from x4 minus A2 from x3. So again, this is minus A2, then minus A1 from x2. This is minus A1 from x2 and minus A0 from x1. Minus A0 from x1. Okay. So this equation is satisfied. All these 4 equations are done. Fine. All these 4 equations are satisfied. Now what next? the last one. What is that? Y equals b naught x1 plus like that. Okay, so let me write here for convenience. Y equals b naught x1 plus b1 x2 plus b2 x3 plus b4, sorry, b naught b1 x1 b1 x2 b2 x3 plus b3 x4 b3 x4. Okay, fine. Now you see, what is the output? Output must be sum of all these signals. There should be a signal common from x1, from x2, from x3, and from x4. Okay, so this is x1 of s. So I will multiply it with a gain of b naught. Okay, so now this is my output variable y of s. Okay, output variable y of s. So what is output variable y of s? It comprises b naught x1 plus what? Plus b1 x2. So there should be a channel like this. This is b1 x2, b2 x3, and finally b3 x4. b3 x4. Okay, so this is what is called the phase variable canonical form. Okay, phase variable canonical form or controllable canonical form. Let us try one example. Obtain the controllable canonical form. Okay, so you are given a system like this. 2 into s plus 1 into s plus 3 divided by s into s plus 2 into s plus 4. Plus minus u of s, y of s. Okay, you have to find the controllable canonical form or phase variable canonical form. So what you have to do first? First we have to find the total transfer function. So what is y of s by u of s? This is in unity feedback form. G divided by 1 plus g of s. Okay, so when you simplify that, you will get 2s square plus 8s plus 6 divided by s cube plus 8s square plus 16s plus 6. Okay, 16s plus 6. Now what next? You can draw the figure. Okay, this is our u of s 1 by s cube plus 8s square plus 16s plus 6. Okay, 2s square plus 8s plus 6. This is y of s. This is w of s, intermediate variable. Okay, so as before, you can call w of s by u of s as 1 divided by s cube plus 8s square plus 16s plus 6. Okay, so as before, you will get w triple dot t plus 8w double dot t plus 16w dot t plus 6w of t equals u of t. Okay, so as we did before, you can call w of t as x1, which implies w dot will be x1 dot, which is equal to x2, which implies w double dot will be x2 dot, which is equal to x3, which implies w triple dot will be nothing but x3 dot t. Okay, so you can do these arrangements and you can write it for yourself. Okay, so eventually you will get your x dot. Eventually you will get your your A matrix like this. X dot equals 0 1 0 0 0 1 minus 6 minus 16 minus 8 into x plus 0 0 1 u. Okay, similarly, what should be your output? Your output y must be equal to what? 6 8 2 into x. You can verify that. Okay, so once you are done with this part, now what next? Y of s by w of s. That you will get 2s square plus 8s plus 6. Okay, so y of s will be what? Or y of t will be what? Y of t will be 2w double dot t plus 8w dot t plus 6w of t. Okay, so from that you can straight away get this. Okay. So in this form, normally we choose the output variable and its derivative as phase variables. Okay, here just for explanation, I have taken up one example like this. Okay, otherwise, if this suppose this numerator was equal to 1. Okay, suppose this numerator was 1. This numerator was 1. Okay, then suppose this was your transfer function 1 divided by s cube plus 8s square plus 16s plus s. Suppose this was your total transfer function y of s by u of s. Okay, so what is basically happening here? We are defining the output variable and its derivatives as state variables. Okay, we are defining the output and its derivatives as state variables. Okay, so the term phase in the phase variable form that comes from physical chemistry. Okay, that comes from physical chemistry where different phases of matter were studied using this particular model. Okay, different phases of matter were studied using this kind of representation. Okay, that is why it is called phase variable canonical form. Okay, so this is one way. Okay, one of the canonical forms or one of the standard forms, right? Next one is observable canonical form. Observable canonical form. It is also called input feed forward form. Okay, observable canonical form or input feed forward form. Okay. Again, let us start with the same example. G of s equals b3s cube plus b2s square plus b1s plus b0 divided by s raised to 4 plus a3s cube plus a2s square plus a1s plus a0. Okay, so this is the output to input ratio. Okay, y of s divided by u of s. Just cross multiply. Okay, so what will you get? You will get s raised to 4 y of s plus a3s cube y of s plus a2s square y of s plus a1s y of s plus a0 y of s equal to what? b3s cube u of s plus b2s square u of s plus b1s u of s plus b0 u of s. Okay. Now what I will do, I will retain s raised to 4 y of s. That's the highest order derivative term. Okay. I will retain s raised to 4 y of s in the left hand side and I will take all the terms to the right side. Okay. I will retain the highest derivative of the output on the left hand side and take all other remaining terms to the right side. Okay. So you see in the right side already there is s cube u of s term. When you take a3 s cube y of s to the right side, they are common in s cube. Okay, so I can group like terms. Okay, so I can write like this, which implies s raised to 4 y of s is equal to what? S cube into what will you get? b3 u of s minus a3 y of s. Okay, plus s square into b2 u of s minus a2 y of s plus s into b1 u of s minus a1 y of s plus b0 u of s minus a0 y of s. Okay. Now what I can do, I will divide throughout with s raised to 4. Okay. So that means y of s is equal to, so when you divide throughout with s raised to 4, here you will have 1 by s. 1 by s into b3 u of s minus a3 y of s plus this becomes 1 by s square. Okay, because you are dividing throughout with s raised to 4. So 1 by s square into b2 u of s minus a2 y of s. Okay, plus this becomes 1 by s cube into what? b1 u of s minus a1 y of s plus 1 by s raised to 4 into b0 u of s minus a0 y of s. Okay, a naught y of s. Now I will define, let my output variable y of s is equal to x1 of s. Okay, so what I can do, I can write this as x1 of s equals what? 1 by s into b3 u of s minus, so y of s is x1 now, okay, minus a3 x1 of s plus 1 by s square into b2 u of s minus a2 x1 of s plus 1 by s cube into b1 u of s minus a1 x1 of s plus 1 by s raised to 4 into b naught u of s minus a naught x1 of s. x1 of s. Okay. So you see, now let me multiply throughout with s. Okay, so what will you get? You will get s x1 of s. Okay, so this s and the numerator s gets cancelled. So here it becomes 1 by s, here it becomes 1 by s square, and here it becomes 1 by s cube. Okay, so what I will do now, I will multiply now with s throughout. Okay, therefore s x1 of s will be equal to what? b3 u of s minus a3 x1 of s plus all other remaining terms, I take it as x2 of s. Okay, so all the remaining terms, I call them as x2 of s. Okay, so x2 of s is, what is x2 of s? x2 of s is 1 by s into, why 1 by s? Because we are multiplying this x1 of s expression throughout with s term. Okay, so you get s x1 of s is equal to b3 u of s minus a3 x1 of s plus 1 by s into blah 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 plus 1 by s square into blah 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 plus 1 by s cube into blah blah blah. Okay, so x2 of s will be 1 by s into blah 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 plus 1 by s square into blah 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 plus 1 by s cube into blah blah blah. Okay, so from here I will get what? x1 dot t equal to what? b3 u of t minus a3 x1 of t plus x2 of t. Okay, plus x2 of t. Now this is my x2 of s. So x2 of s is what? x2 of s is equal to this is actually x2 of s by s. Okay, this expression by itself is x2 of s by s. Okay, when you multiply throughout with s, what happens? This becomes x2 of s. So what will be x2 of s? x2 of s will be equal to 1 by s into what? b2 u of s minus a2 x1 of s plus 1 by s square into what? b1 u of s minus a1 x1 of s plus what? 1 by s cube into b naught u of s minus a naught x1 of s. Okay, now what I will do? I will multiply throughout with s. Okay, so this I will call as x3 of s divided by s. Okay, x3 of s divided by x3 of s divided by s. Okay, so if you multiply throughout with s, what will you get? You will get s x2 of s equals what? b2 u of s minus a2 x1 of s plus x3 of s. Okay, so in time domain, what does it imply? It implies that x2 dot t equal to what? Equals b2 u of t minus a2 x1 of t plus x3 of t. Okay, so second state equation. See, it is in the form x dot equal to ax plus bu. Okay, now so what will be x3 of s now? x3 of s will be what? x3 of s will be, you multiply throughout with s. Okay, x3 of s will be what? 1 by s into b1 u of s minus a1 x1 of s plus 1 by s square into b naught u of s minus a naught x1 of s. Okay, so if you multiply throughout with s, what will you get? S x3 of s equal to what? b1 u of s minus a1 x1 of s plus what? Plus x4 of s by this thing. Plus x4 of s. Okay. So what is this? This is nothing but x4 of s divided by s. Okay. So from here we get what? x3 dot t equal to b1 u of t minus a1 x1 of t plus x4 of t. Okay. So now from this, what will be your x4 of s? X4 of s will be what? X4 of s will be what? Will be 1 by s into b naught u of s minus a naught x1 of s. Okay. So that means sx4 of s equal to what? b naught u of s minus a naught x1 of s, or it implies in time domain. What does it imply? It implies x4 dot t equal to b naught u of t minus a naught x1 of t. Okay. Now let us draw in the signal flow diagram. Okay, let us draw signal flow diagram. So here we have got all the state equation, right? Now what is the output variable here? It is output variable is x1 of t. Okay, so we can straight away write our output equation y of t as what? Y of t will be what? X1 of t. That means 1 0 0 x of t, right? So let me club all the equations here. What was x1 dot t? x1 dot t, x2 dot t, x3 dot t, x4 dot t. Okay, so x4 dot t was b naught u of t minus a naught x1 of t. What was x3 dot t? b1 u of t minus a1 x1 of t plus x4 of t. What is x2 dot t? b2 u of t minus a2 x1 of t plus x3 of t. And what was x1 dot t? It was b3 u of t minus a3 x1 of t plus x2 of t. Okay, let us see how the signal flow graph looks like. Okay, so first equation x1 dot t. This is 1, 2, 3, 4. Okay, so first equation, how will be the signal flow graph? So there is a node x1 dot t. Okay, this node should be x1 dot t. Okay, there should be an input branch. Okay, u of t with a gain of b3. Then there should be x1. Okay, whose gain must be minus a3. Then there should be a path from x2. This is x2 of t. Okay, there should be a path from x2 with a gain of 1. Now, second equation, what will you get? Again, there should be an input signal u of t with a gain of b2. So this must be your x2 dot t. Then there must be a gain from x1 at a gain of minus a2. Then there should be a branch from x3 of t with a gain of 1. Okay. Then similarly 3. There should be again a u of t. Gain should be b1. This must be x3 dot. Right. So there should be a channel from x1 at a gain of minus a1. And if there is a node x4, there should be a branch with a gain of 1. And finally, we have u of t for the fourth equation. Okay, the gain is b naught. Okay, so this must be x4 dot. So there should be, if there is x1 signal, there has to be a gain at negative feedback minus a naught. Now what we have to do, we have to logically connect all these things. Okay, we have to logically connect all these points, join all these branches. Okay, so you see, anyway, there has to be an input node u of t. Okay, input node u of t, right? So what is the this thing? So you see there should be x1, x2, x3, x4. Okay, so there should be x1, x2, x3, x4, right? So let me mark this as x4 dot. Okay, so this x4 dot, I am integrating it once, 1 by s. So what will I get? I will get x4. Okay, now let us try to satisfy like this other equations. Okay, so so you will get x4, right? Now what is x4 dot? X4 dot is x4 dot is b naught u of t. Okay, and from x1 there should be a branch from x1. This is my x1 t. Okay, at what gain? At a gain of minus a naught. Okay, so here minus a naught. Okay, minus a naught. We are satisfied with the fourth equation, right? x4 dot is b naught u of t minus a naught x1 of t, right? Now what's the third equation? x3 dot. Okay, what is x3 dot? There should be an x4, a signal from x4 at a gain of 1. So that means this is x4. So this must be what? X3 dot. Okay, so x3 dot must be what? X4, then plus blah blah blah. So there should be a branch from the input at a gain of b1. So there should be a signal like this, b1. Okay, then what next? Another signal from x1 at a gain of minus a1. So this must be minus a1. Fine. Now coming to the second equation, what is that? So plus x3. Okay, so that means x3 dot. This is x3 dot. It has to be integrated to get x3. Okay. Now there has to be a signal from x3 at a gain of 1. See the equation 2. X2 dot is sum of all these three components. Okay. So that means there should be a gain of 1, and this node must correspond to x2 dot t. Okay. So what is x2 dot? x3. So this is x3 plus what? Plus b2 u of t. That means there should be a branch from u at b2. Okay, b2 u of t. Then what? Minus a2 x1 of t. A signal from x1 at a gain of minus a2. Minus a2 it is, right? Minus a2 x1. Correct. Minus a2 x1. Okay, so we are done with second equation also. Now what next? The first equation. Okay, what is that? x1 dot t is x2 plus. Okay, so this is x2 dot. So that has to be integrated so that we get x2, and now x2 plus. But so this so this must be no 1 minute. So this is x2. Okay, this is x2. So this must be a gain of 1. This must be x1 dot. Okay, when you integrate, you will get x1. Right? So what is x1 dot? X1 dot must be x2 plus. So this already is satisfied. It is x2 plus what? X2 plus b3 u of t. So there should be b3 u of t plus what? Plus x2, that's already done, minus a3 x1. So minus a3 x1. Okay, so this is the part. Okay, this we are done with, right? Now what is y? Y is same as x1 of t. So this is nothing but equal to y of t. Okay, so in this way you can obtain what is called observable canonical form. Observable canonical form. Okay, so all the states can be seen from the output equation. Okay, this is called observable canonical form. So these are the main two standard canonical forms. Okay, there are other canonical forms also, like Jordan canonical form, then diagonal canonical form, etc. Okay, so we will stop here for the day.